Of all 2 trillion galaxies in the observable universe, the Milky Way, our home, is humanity's most important one. Spanning roughly 100,000 light-years in diameter, it holds between 100 and 400 billion stars, including our own Sun. But some scientists think there could actually be many more stars than meets the eye, and that there's a lot more going on in, or should we say parallel to, the Milky Way than we currently think. This is Unveiled, and today we're answering the extraordinary question, is the Milky Way hiding a parallel universe?
Do you need the big questions answered? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one, and ring the bell for more thought-provoking content.
On a clear, moonless night, somewhere where the view is entirely untainted by light pollution, the vibrant Milky Way can be seen trailing across the sky. In some places on Earth, its shine dominates between horizons, wrapping around the planet like a giant cosmic ring. Its name reflects its appearance, and it has forever been one of the most prominent objects visible at night, a must-see spectacle for any citizen of Earth. For as long as humans have existed, we've curiously pondered the nature of our place in space and of our home galaxy. Modern astronomy has given us an abundance of knowledge about the Milky Way, from its size and mass to its rotation period, thickness, and luminosity. For example, we know the Sun takes approximately between 225 and 250 million years to do an entire lap around the galactic center. But regardless, there still remains so much we don't know about our own celestial neighborhood. And just recently, scientists may have landed on something pretty massive. They've started to look into an entirely new form of star, a type that might also be scattered all across the sky. While such stars may be in abundance throughout the universe, though, they're also almost completely invisible. They're called mirror stars, and are actually a fairly common prediction of certain dark matter models. New science increasingly hypothesizes that these stars are indeed physical, that they do exist, and then that the Milky Way is home to countless numbers of them. Which brings up some questions right away. Like, isn't dark matter notorious for being impossible for humans to detect? How is it then that mirror stars dependent on dark matter are suddenly thought to be everywhere? How can the galaxy be full of them? And is it possible to prove that they exist if they do? Surely such objects could only ever be theoretical. But astronomers are increasingly confident that they have cracked the secret behind them, and therefore believe that they're within reach of detecting mirror stars beyond any doubt at all. When they do, it could spell a monumental paradigm change in our understanding of the cosmos. But first, let's set the scene for some context. For a while now, dark matter's existence in general has been considered definite, but we still know little about its origin or composition. This is because one of the key problems is that we've only ever observed it indirectly, via its gravitational interactions with regular matter. In general, while dark matter doesn't interact in any way that's visible to the eye, its domination of the universe is evident in the motion and movements of large-scale structures. For example, one of the first hints toward dark matter came from analysis of galaxy rotation curves. It was previously hypothesized that galaxies would rotate slower on their edges than in the center, but measurements said otherwise. They showed rotation to be constant regardless of where you are in the galaxy. This then is indicative of a great deal of invisible matter, dark matter, spread evenly across the galaxy. Further observation went on to find that 27% of the entire cosmos is composed of dark matter, with only 5% being regular matter. This is now old news, but when it was first understood, it was pretty shocking. And many different ideas on exactly how it works have been put forward since, none of which solve dark matter completely. That last part might soon be about to change, however, with an emerging crowd favoring what's known as the atomic dark matter model, or ADM. While most previous theories hypothesized dark matter to derive from one singular particle, with that particle behaving unlike anything else in the standard model, ADM effectively believes in a second standard model, populated by dark particles with a dark electromagnetism equivalent, complete with a dark photon. In short, if it does exist, then this is very literally new physics. Like opening a favorite book, but realizing that there's an entire crucial chapter that you've never read before. Or even that there's an entire second half that you never even noticed. What's more, many of the principles at play here have seemingly been predicted by and via other mysteries relating to the Standard Model. For example, much of the speculative mirror twin Higgs cosmology also suggests a whole dark section. There are then further, again quite speculative, musings around the possibility for dark matter electrons, protons, and neutrons specifically, and all potentially staging not just gravitational interactions, but nuclear too. Until now, such ideas have felt a little loose, but things seemingly get significantly more interesting with ADM in particular, since it's a model which allows for atomically bound states, i.e. for systems bound together with fundamental particles. If true, and in short, this would mean that dark matter can bunch or collapse to form larger objects, much like we know the atoms of regular matter already do. Which brings us back to mirror stars, arguably the most interesting and dramatic predicted dark matter objects of all. At their simplest, these are literally stars created out of dark matter. It's then thought that they emit dark photons from their energetic centers, akin to regular stars. And, at this still quite early stage, one of the best things about them is that researchers do think we can realistically hope to observe them, because it's thought that mirror stars capture tiny quantities of regular matter as well, which then sinks down to their core. This is comparable to the Sun capturing dark matter, which is an idea that's actually quite common in various cosmological theories. Clearly, a star is a sizable prospect. Even in the vastness of the universe, stars are massive enough to attract and warrant attention. Here, then, they might finally offer a route or gateway that's substantial enough to uncover the mystery of dark matter. Scientists believe that the captured regular matter in such objects will accumulate over time, turning into what have come to be known as nuggets. Small pieces of detectable material indicative of a wider truth. These nuggets, if they do form, should be heated within the core of a mirror star, which should lead to electromagnetic radiation that's relatively simple to detect. If the theories prove sound, then mirror stars should ultimately serve as emerging beacons, ready to light our way to full disclosure on dark matter. Unfortunately, while it all works on paper, it's thought that mirror star nugget emissions will be extremely faint. It's not as though, now we suspect that they're there, we'll just start spotting them all over the place. However, the science is moving quickly. Towards the end of 2023, a Canadian team led by Isabella Armstrong submitted a paper detailing what these emissions would look like, again revealing, theoretically, that they'd send off dim signals since they're much redder and fainter than regular stars. It's perhaps a little vague right now, but thanks to work like this, the path is certainly open today for telescopes to search for these signals directly, and to finally give some proper insight into the true nature of that otherwise mostly unknown 27% of the universe. Currently, one issue is that there's an abundance of dim objects we do already know about in the cosmos. From white dwarfs to planetary nebulae, there are endless standard matter astrophysical phenomena that could be mistaken for our dark universe nuggets. Thankfully, cosmologists have already devised and suggested methods to distinguish between nuggets and regular matter sources. It is a very tricky skill to master, but it seemingly is possible. Nevertheless, even the mere suggestion of mirror stars is huge news. For one, it means that sky surveys might now be able to add dark matter to their observations list. Further methods of detection could result from that, and the route to unveiling the mystery of matter will be lit brighter than ever before. More broadly, mirror stars represent our first look at what some have already dubbed an entire mirror universe. As the underlying mechanics of the phenomenon are still unknown, this still counts as mostly speculation. However, it's an idea that bears similarities to many more physical theories on the potential for parallel worlds. In this case, it could be that an entirely alien plane of reality has actually always existed all around us. It's just that we've never even begun to understand that it's there. From here, there are all kinds of follow-on questions. If there is a mirror universe, then is there mirror life there? Would such a place simply be another version of our own universe, except with the fundamental particles reversed? Or would there be more and less predictable differences between there and here? Let us know what you think in the comments. Socrates once reputedly said, quote, "The more I know, the more I realize I know nothing," end quote. And now there's a strong chance that the discovery of mirror stars will trigger many more new questions than solve old ones. It could potentially cause an entire re-evaluation of the standard model. But that's how the Milky Way could be hiding a parallel universe.
The universe is 13.8 billion years old. Modern humans have walked Earth for only the last 300,000 years of that. So what could have happened in the long stretch of time between the Big Bang and the emergence of Homo sapiens on this planet? There's a lot that we know and a lot that we don't, but some theories bridge the gap in more unusual ways than others. This is Unveiled, and today we're answering the extraordinary question, are there ancient humans living in the Milky Way?
Are you a fiend for facts? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one and ring the bell for more fascinating content?
A headline-making study in June 2020 claimed that there could be dozens of alien civilizations living in our galaxy, the Milky Way. 36 was the most often cited figure, although the upper estimate went past 200. That's 200 individual alien societies reportedly living on our doorstep, in cosmological terms. Now, let's be clear, there's so far zero actual proof that there are any alien civilizations out there. The general scientific consensus is that there must be, but we've so far found nothing by way of hard, irrefutable evidence. The Fermi paradox continues to plague our search for extraterrestrial life. The 2020 study, though, was inspired by various projections and predictions, including the Drake equation. Its claim of 36 neighboring alien groups has since been debated and disputed. We ourselves released a video, and there's a link at the end of this episode. But say there are other bands of living beings, and say they really are not so far away from us, then what are they doing there? Some theories, most notably the zoo hypothesis, argue that nearby, superior alien groups are busy watching and possibly experimenting on us. Others, like the dark forest theory, suggest that any alien society trying to survive will wisely remain as quiet and undetectable as they possibly can. There are, though, some more unconventional theories to suggest that if there are aliens out there, they might not be all that different from us at all. One study, published in December 2020 by researchers at Caltech, aimed to map the potential for life in the Milky Way more precisely than ever before. Paying close attention to the probability that life will, and does eventually self-annihilate, as well as the likelihood of the emergence of life, of abiogenesis in the first place, it delivered some interesting results. It found that life was most likely in the Milky Way around 8 billion years after it formed and around 13,000 light-years from the galactic center. Considering that we appeared more than 13.5 billion years after galaxy formation, and that we're now 25,000 light-years from the galactic center, this would suggest that humans are doing quite well for themselves. According to the study, we're here far too late, in completely the wrong place, and are therefore way past the peak of life in this galaxy. And yet, we're surviving. Well done, us. But what do these conclusions infer about the rest of life in the Milky Way? One takeaway is that, if the study rings true, there should be a band of space almost halfway between us and the heart of the galaxy, 13,000 light-years from the center, wherein life is much more likely to exist than anywhere else. But another is that most life in this galaxy should have emerged more than 5.5 billion years before we did. And if that's true, then what happened to it? The short answer is, it killed itself off. The Caltech study highlights the key role self-annihilation likely plays in how far any civilization can reasonably spread. Away from the study, the general idea is that all life dies before it gets big enough to be noticed. The slightly frightening assumption, then, is that the same thing will happen to human beings. That we'll only ever get so far before we destroy ourselves from within. But still, if even just one such civilization did manage to survive, then they would certainly be considered ancient to our lowly minds. Recorded human history barely goes back 5,500 years, but now we're imagining life that's 5.5 billion years old. Not that such a hypothetical life form should ever automatically be billed as ancient human, even if we could prove that it exists. The chances of anything else separately evolving to be even slightly recognizably similar to us are extremely low. The aliens we see in movies and read about in books are all too often humanoid in nature, with eyes and hands and heads and some kind of audio language. But in reality, they'd probably look nothing like us, and according to some theories, might not even be carbon-based. The picture gets a little stranger though when ideas on panspermia get thrown into the mix. Subscribers to various ancient alien theories argue that biological material could have been distributed all across the universe in the time since its inception, that we think we're rare on Earth, but that actually we're just one of countless locations that life has reached. And this is what panspermia amounts to: the spreading of life throughout the cosmos, usually via space dust, asteroids, and colliding planets. Directed panspermia, though, brings a degree of agency to the table. The idea now being that life is deliberately spread to other worlds by advanced, traveling alien species. Again, there's little by way of credible mainstream science to suggest that this is what actually happened here on Earth. But with such a long time gap to fill between the start of this planet and the start of humankind on this planet, fringe theories abound that ancient humans either seeded here or arrived and settled here millions or billions of years ago. In this version of life, the universe, and everything, it's as though we're a colony established in the distant past by an older, more advanced version of ourselves. Through the lens of the Caltech study, we might imagine that those older, superior humans had emerged long ago, out of the optimum region for life in the Milky Way, 13,000 light-years away from the galactic center, and 12,000 light-years away from us. They then brought their human civilization here before carrying on their merry way into the rest of the galaxy. But one final consideration for today's question is, what if we aren't the product of panspermia, but we're actually the ones facilitating it? Another popular fringe theory is that life did originate on Earth, but the history of human evolution isn't what we generally think of it as. Instead of the earliest hominins emerging around 9 million years ago, and modern humans about 300,000 years ago, some claim that there were humans before this, and that they became advanced enough to leave Earth forever. Importantly, there is, again, precious little scientific or historical evidence that this really is the case. It's an idea, an unsubstantiated theory, but one that's captured the imagination of many a science fiction writer before now. Again, it allows us to imagine that the Milky Way is actually full of life, perhaps boasting far more than just the 36 civilizations suggested by the June 2020 study. Only in this version of events, many of those could be our ancestors. It's just that they started on Earth and then set off to the stars, just as we're trying to do today. The biggest argument against this line of thinking, however, is that it assumes that Earth is basically the center of everything. That's despite the overwhelming statistical likelihood that it isn't. If either panspermia theory is true, that we were spread by others, or that we started on Earth and are now spreading elsewhere, it's much more likely the first one. To bring in the Caltech study one final time, even had humans somehow instantly appeared on this planet at the moment that Earth was born, an obvious impossibility, then they'd still be only 4.5 billion years old, which would still place us as arriving later than the optimum time for life in the Milky Way, 8 billion years after it formed. The idea becomes marginally more palatable if we imagine that humans didn't start on Earth, but were seeded here instead by other humans. Then, theoretically, we'd have so much more time to play with across the history of the universe. Our story could be pushed further back to a time before Earth and a time within Caltech's optimum parameters. And it can be pushed further forward, because we're no longer confined to just one world. Earth becomes just one of many that we might have visited in the past, or in the future. And suddenly, the rest of the Milky Way is our playground. But ultimately, all of those stipulations require us to make some gigantic leaps in our understanding of why we're here, what it takes for us to survive, and how significant we really are in the universe. More and more scientists are growing to accept that alien life must exist somewhere in space. But human life? Perhaps we'll only believe that when we see it.
What do you think? Is there anything we missed? Let us know in the comments, check out these other clips from Unveiled, and make sure you subscribe and ring the bell for our latest content.